Right, today we're going to start looking at how to graph these on the graphing calculator. The technology is nice. I'll be honest with you, it can make it a lot faster. But you need to know all your options on the calculator then. Okay, so let's just kind of, when we do this one, let's just do this one a little bit by hand first, and then we'll see if we can get the graphing calculator to actually do the same thing. All right, so this one right here, we're looking at cosine. And so let's just make a little note of our amplitude, period, and phase shift first off, right? Let's see if we can figure that out, because at least this particular year it has fallen on a Monday, so we'll see if we can remember some of this stuff. So how about amplitude for this one? 1, very good, because there's no number out front. How about the period? Is 360, very good, 360 degrees. And the phase shift happens to be 90 degrees to the right, correct? All right, so normally what we would do then is we go over here at 360, right, and then this would be 180. Okay, this is the way we've been kind of attacking these problems. And then what we did is we said, well, let's graph everything but the phase shift, right? Or at least get a sketch off to the side of everything but the phase shift, I think is how many of us have been doing it. I think some of you have been going in and making a table, which is fine. But basically, if I were to graph everything but the phase shift, so in other words, if the amplitude's 1 and period's 360, isn't that just regular old cosine? Really, I haven't done anything to it if there's no phase shift, right? So hopefully you can agree that cosine pretty much does that, correct? That's if it's regular cosine, right? And so what we're going to do, and I know some of you have been kind of putting that one in dashed. If that's what you've been doing, go ahead and do that. Or if you have your sketch off to the side, do that. Now what we have to do is shift it 90 degrees to the right. Well, 90 degrees happens to be 1 tick mark in this case, correct? So let's just go ahead and move it just 1 tick mark to the right. And so that's really what phase shift does. Okay, and so then we would have to finish this one off, and it should be no surprise that that's what it would do, right? And again, there are arrows on the end of this because it does keep going. It's not like it stops out in the middle of nowhere, all right? And so that's what we should get, at least that's what we think we should get when we go to the graphing calculator, correct? So why don't you go ahead and sketch that one in there so that you have something written down so that once we go to the calculator, you have something to compare it to. So take a second and do that. Oh, great question. The question was, is there a theta button on your calculator? Yes, it is. But we actually do not want theta right now because that's actually for something we're going to do later in the year. That's actually going to be kind of cool. But right now, we're not going to be able to use theta in these, so we're going to have to use x. We're going to have to keep it as just an x. Remember, it's just an input variable. Okay? Y being the output. So has everybody got a sketch down there? Ready? Okay, so we know what we've got. We've got cosine of theta minus 90 degrees, or x minus 90 degrees. Okay, so let's go to the graphing calculator. Whoops, we don't want that one. So what you want to do is go to y equals. All right. Now, first off, I have had my stats class working on some stuff. If you have any of these plots up here, you see plot 1, 2, and 3, if any of them are highlighted, you do not want them highlighted. So all you have to do, that means somebody turned them on. So all you have to do is go up there, let's say plot 1's turned on. I'm just going to go up there. You see how plot 1's now blinking? And just hit enter. It's like a toggle switch. If it is on, doing that, I'll turn it off. If it is off, doing that, I'll turn it on, right? Okay, for those of you unfamiliar with what the word toggle switch means. So once you're in y equals, you want to actually, if there's anything else in there, just clear it out. For example, maybe you have just some gibberish in there, okay? And so all you have to do is just clear that out, and then you can enter what we want, okay? And so let's go ahead and let's graph y equals cosine. So here's cosine. But what do you notice happens right away when you type cosine in? Without me doing anything, it comes with a parenthesis. Here is why your textbook likes you to write these equations in the other form. Because that 2 or that k that I like to put out front is already multiplied in for this. But I don't think technology should be a good reason to necessarily do things one way or the other. Because I think writing equations is way easier with k out front, right? So all you're going to have to do here is just multiply k in, if we have it that way. But our problem doesn't have that. We just have x or theta minus 90 degrees. Okay, so x, right, minus. Now make sure, a lot of people, x is this button right here. This is your variable button. It's x, t, theta, and n. Okay, there's your theta. But we don't want theta to come up right now. Because if theta came up right now, we'd be graphing what's called polar coordinates, which we're going to do later this year. Okay? So it's x minus, and now how much? 90, right? Now, some of you may be looking for a degree symbol. Okay? I believe there is one on here somewhere, but we don't really use it. So how does my calculator know Yeah, we're in degree mode, right? We should probably check that out. Okay. So, well, I'm done typing it in, right? You see how I closed it off? Let's just, before we graph, let's just go ahead and check our mode. So mode's this one right here. I am in degrees. Excellent. How are you in degrees? I am. Okay. So y equals, there we go. You got it entered? Any questions? All right. Now what I'd like everybody to do right now is go to Zoom. It's a little Zoom button there. And go to number 6. That way we should all get the same graph, right? You with me on that? If we all zoom to the same amount, zoom standard. And what zoom standard is it goes from -10 to 10 on the x-axis and -10 to 10 on the y-axis. It graphed. Not much, but it graphed. You see this little spot over here and that little spot over there? That's what it just gave me. Well, that's definitely not what we got on the notes, is it? That's not what we have here. Uh-oh. What did we do wrong? We're in degree mode. Why didn't that graph? Why? What's going on? Yes? Oh, okay. What somebody said is it did graph. Because let's face it, we saw it graph something, right? It just didn't look like this. But that person that said we were not in the right zoom setting. Okay. So really, yeah, it did graph. But wait a minute, what mode were we in? Well, either way works, actually. I prefer radians. And somebody said we should switch it to radians. Either way works. You still have to set your window properly. Because I told you that it just went -10 to 10, correct? And I'm in degree mode, so that means -10 degrees to +10 degrees. So we just graphed that. Right? It went from -10 degrees. You agree that's about where they are? Right? Isn't that where -10 degrees and so what do we got to do? We got to say don't graph that. We have to tell it graph -360 degrees to +360 degrees. And let's face it, we can just go from -1 to 1, right? Isn't that what we've got here? So how do we tell it to do that? Well, you go into what's called window. See right next to zoom there? Window. Look at, I'm -10 degrees to 10 degrees for my x or my theta axis, right? What do we want it to be? What does it say on your paper that you graphed? Your x went from where to where? -360 to 360. Okay, now careful. Don't try the subtraction button for negative. Okay, use the one down here by the next to the enter button, the one that says kind of opposite. And then 360. Everybody with me on that? Because I'm in degree mode, right? And then 360 degrees. What do you think x scale stands for? What does that mean? Not yet. Nope. Y max and min are down here. Yep. Good try, though. Basically, it means how often would you like a tick mark? How often would we like a tick mark? Well, how often did we put it on ours? Every how much? Every 90 degrees? Well, let's tell it every 90 then. Because that's what it's asking. How often would you like a tick mark? Well, on ours, we kind of went from -1 to 1 because the amplitude was 1, right? Well, for y, let's do -1 to 1. Again, watch out with your negative. Do this opposite button down here. Opposite of 1 for the minimum, +1 for the max. Do you think y scale then is every tick mark? Do you think 1's probably enough, huh? And don't mess with your resolution or any of the other stuff, okay? So does everybody have their window looking like this? Okay, so let's think about this. We're in degrees. We've set our window to degrees. We've set our window to make the amplitude right. We told it to make our tick marks the same. This better look like ours, right? We sure hope so. Let's find out. Because I can't think of anything else. Oh. Well, isn't that exactly what we have?
That one looks nicer.
Well, yeah, I'm sure that one looks nicer. And I believe one of you made this observation last week. What did we just graph? Really, what did we just? We just graphed sine, didn't we? It's just a 90-degree shift of cosine. Okay, to the right. Okay? Very good. Okay. So that's kind of how it works. Can you use radians? Let me just show you really quick. You don't have to change anything, but please pay attention because you might need to do it in radians at some point. Okay? Everybody with me? Everybody gonna stay with me? All right, so I'm going to switch to radians, and then I'm just going to graph it again. All right, ready? Do you think this will look the same? Wow, yeah, that does not look the same at all. It looks like one of my kids getting crazy with a crayon. Is about what that looks like, doesn't it? Or a marker, maybe. What just happened? Believe it or not, that's right. That is the graph. What happened? Yeah. Yeah, window has to be in radians then. Now let's think about that. I just went to 360 radians. And 1 radian's 57 degrees. So 360 radians is a lot, right? And so what should I set it to? It's not negative 360 degrees, but negative, what's the same thing in radians? Negative 2 pi. Very good. 2 pi. Pi. Okay? But now watch what happens on my calculator. My calculator doesn't like that very much. Watch what my calculator does once I hit down. It just puts the decimal down. But isn't that the same thing? Isn't that negative 2 pi? It is negative. No. And then we'll go to 2 pi. Boy, I'm really missing that button. There we go. Now what's our, well, it was 90 degrees. Well, what's 90 degrees in radian language? Pi over 2. So that's what you would put there. Well, I really cannot hit that button at all. All right, pi over 2. Do we really have to change our y, though, that we switch to radians? No, that's the output, right? Not the input. So this should work. So this should give us what we had before, correct? Let's find out. So in other words, we better get sines graph here. Uh-oh. What happened? Ah, look at that. It says 90 degrees yet. Uh-oh. All these things to think about. So my phase shift isn't in there right. What do I have to write there? Pi over 2. Now, hopefully this will be right. Aha. There is sine. And let's face it, isn't that the exact same thing it did 2 minutes ago? Unfortunately, the calculator is only going to do what you tell it to do. It does not know your intent. All right? Any questions on that? So have I said at any point so far if you have to do it via degrees or via radians? I have not, have I? You need to do it whichever way you can do it. So why don't we try another one? Let's try number 2, and let's just do it on the calculator. All right? So number 2 you have there. You have 3 sine of all of that stuff. Because sometimes just getting an idea of all this stuff will help you understand what's going to happen. What's our amplitude on this one? 3, okay. And our period? 360. In phase shift, 90, correct? Am I going to have any problems typing this one in? Well, let's find out. Well, period's 360 this way, right? And 360 this way. Is that what we had? Well, that's what you have your window set at, correct? I changed mine to radian, so I'm going to have to fix it, okay? And so then phase shift is 90. Did we really do anything with phase shift last time when we typed it into the calculator? Not really, but period was important, right? Because that helped us figure out what to set our window at, and it also helped us figure out what to make each tick mark, right? Because we want to have those 4. What else is probably going to be important for us to change? What's that? Yeah, that. And where does that head up? That 3 and negative 3, where's kind of amplitude show up in your window? What measurements is that? Y min and Y max, exactly. We have to make it probably a little bit bigger, right? Otherwise, what's going to happen? The graph's going to go off the screen and then come back and then go back, and it's going to look crazy, all right? And so we have to kind of set that up. All right. So I'm going to have to change a lot of things because it seems as though you're pretty comfortable with degrees. Am I accurate with that? You're pretty comfortable? Okay. So I'll switch mine back to degrees. So 3 sine. You notice how I'm typing right over the top, and you can do that, or you can clear it, whichever way you're more comfortable with. And then it gave me the parenthesis already. Okay. Now I can't do theta, but I can put an input variable of x, right? And then minus, again, this is the actual minus this time. Don't do the opposite, okay? And I'll show you in a second. Remind me to do that. I'll go in there and put the opposite, and I'll show you what it does, all right? And so do you agree that's our graph? Okay, so let me change my window. So negative, that's your opposite, 360, right? 360, because that's what we decided. And then what was our each tick mark? What was it on there again? It was 90, is that what it was? 90. How about these? You said these are no good? Negative 3, positive 3. Is that still good though? Y scale still being 1? Yeah, 1, that makes sense, right? Or you could change it to 3 if you're more comfortable with that. But at least now we're going to see 3 tick marks on the way up, right? All right. Well, let's find out what we got.
Oh, you're still in radians.
Ah, very good. I'm still in radians, aren't I? All right. So we got to change that. I wanted to see if anybody was going to figure that out. Because let's face it, sometimes technology is more problem solving than it's helpful. All right. Now let's try it. Oh, that looks much better. Yeah, upside, it's like, now how would you state the upside down cosine? It's basically just negative cosine, right? That's what that negative out front does, reflects it over the x-axis, right? Now, let's say you didn't know these points very well. Another thing you can do on the calculator is you can have it actually give you a table of values. Okay? So let me show you something first. Up here is table set. Let's set the table so that I get the information I want. So right above window, so hit second and then window, it's asking you, well, how would you like the table given to you? Now let's face it, when we grabbed it, we started at 0, kind of figure out the positive side, and then we just mirrored it on the negative side, right? So let's go ahead, let's start at 0. That's what they want to know. Hey, what's that little triangle thing? Yeah, what is that again? It stands for change, but it's the Greek letter delta. Very good. It stands for change. So that says, how do you want your table to change? Well, how much is your tick mark going up on this graph? Going up by 90, isn't it? So why don't we just have the table go up by 90? Okay, because I'll be honest, you can have the table go up by whatever you want. Okay, and leave those on auto. Don't mess with that. And if I were you, I'd be writing some of these buttons down on your calculator, all right? So now I've told the calculator how I would like my table formatted. So now let's actually go look at the table. It's right above graph. See graph in the table? So second, graph. Well, there's just a whole bunch of values there. There's your theta y table made for you. And here's the one thing I really like. Let's say you really messed up and you wanted to see some of the negatives. So everybody's attention up here. Watch this. I want to see some of the, you just hit up. And it just keeps giving you more values. All right, or you hit down and go get more values. Okay, so you should be able to get a pretty accurate graph. You've got all these points. So what do you think would have happened if I would have said have it be the change in XP45? Well, it would have given me all the points in between these. It would have gone up every 45. Okay, so pretty nifty what they can do, correct? Do you have any questions so far on what the TI-83 can accomplish? But again, it's only going to do what you tell it to do. We have some people looking here. Are we not getting the same thing?
I'm not. No, I'm not. I feel. Oh, that's
So go to
table set started.
Yep. Go to table set. Yep. I started at 0. You can start wherever you want, right? But it doesn't make sense to start at like 1,000, right? It doesn't really make sense to start at 2 for this one. And then I said, make my table change every 90 degrees. Again, I could go in there and change that if you want, but, you know, to show you, but 90. And then you can go get the table. Maybe you want it to go up by 45, and so that's what you would tell it to do. Got it? Okay, good. Everybody good to go on to number? There's a couple on the back. We'll try them. All right, what else we got here? Oh, well, we did that one. Next. Again, it's helpful to get an idea of what's going on here. Uh-oh, what's different about this one? Yeah, that half. Let's face it, on your calculator, it has to say y equals, right? So we got to get rid of that half, but we can't just erase it, because then it's not the same problem. So how are we going to deal with that? Yeah. Yeah, multiply both sides by 2 would do it, which is the same thing as dividing both sides by half, right? Same thing. Yeah, let's see, where does that 2 go? That's the big question, isn't it? What do you do with that 2? All right, so let's think about that. When we do the trig, normally we would do that theta minus 180 first, right? Then we would take sine, do what the sine function tells us to do, and then we would multiply by something, correct? So that's actually where the 2 goes, just like the person asking the question said, well, does that go and become the amplitude? And that's exactly what happens. It doesn't tell me to double the angle. Right? It's saying double whatever this gives you, please double it. And isn't that how we would do it? Just multiply it by 2 in the end there. But let's face it, normally we would think to put that at the end then, right? But we have to kind of put it out front for it to actually work out the way we want it to. And so when we go, we know the amplitude's 2. Period is, well, that's 360 again, isn't it? And phase shift, this time 180 degrees. So we know 360 is going to be out here. We know 180 here. And 90. So again, you notice I like to go figure out what to make the tick marks. So do we have to change our window for this one? I chose my words carefully there. Yeah, do we have to? No, right. Because we're going to fit, right? Because we're already at 3, exactly. So it would fit. But if you feel more comfortable changing it to 2, is there anything wrong with it? No. I wouldn't change it to 1 because then you're not going to see everything, right? But your window's pretty well set up right now, isn't it? So go ahead, type that one in and see what you get. So this time, am I going to have any problems this time? I don't know. Tough to say. Y equals 2 sine, again, okay, of x minus, boy, I don't have to change much at all, do I? 180. Well, this should be about it, huh? Now, you notice what happened on this one, though. It went, some people say that, oh, you didn't write the 2, right? But you see that little arrow? That means that I had to go beyond what it could handle, right? And so if you want to see that, you have to come back this way and see what's there. See, there it is. Okay? It ran out of room. That's all that little arrow means, okay? And so, ready? It should work, right? My window should be right. Okay, let's find out. So why is it not going all the way to the bottom, then? Yeah, it's on negative 3 and 3, exactly. But so is this right? Yeah. It should go up to 2, down to 2. Yeah. Okay. So another way you could graph this one is this is really y equals negative 2 sine of theta. It just got reflected. It's the same thing. Again, if you wanted to go to your table, you could set that up, get the points you want, and you'd be good to go. How are you doing? Any questions? Pretty nice. So once you get the hang of it, right, you got to know what kind of things can go wrong and why it might give you some strange graphs, right? Oh, I was going to show you on that last one what would happen if you put the opposite, right? Somebody was supposed to, well, that was actually a while ago, but we'll do it on this one. So I'm going to go in here and just hit the opposite instead. Do you think that'll change my graph on this last one? What do you think will happen? Take a guess. Well, it'll do it, I think. We'll find out in a second, but I'm pretty sure it will. What operation's really happening there right now, then? With the x and the 180, that happens to be negative. What operation's actually happening? Nope, it's not subtraction. Multiplication. So I just told it to do it 180 times instead of 1. Didn't I? Isn't that what I just told it to do? So it's going to do what I told it to do. It's just going to do a whole lot. In fact, I'm saying it's missing quite a few, actually. But it did the best it could with what it had. Yep. So there's way more in there. So make sure that you type the right button instead of subtraction or opposite. Make sure you type the one that you actually want it to be. Okay. So how about we go try the last one? Everybody ready to do that? Okay. What do we got? Tangent. All right. So let's do an amplitude here. Yeah, NA, just because it's not measurable, right? Those numbers out front do still affect things, though. So be careful. Whenever you have asymptotic stuff, make sure that you give your y values plenty of room. All right. Don't just try 1 and -1. You're probably not going to see a whole lot. How about period? Ooh, very good. I thought I'd get somebody on that one. Why is it 90? Because really, the way we write it is this way, correct? But then theta plus what? 90, the way we write it? Agreed? Whoa, that was weird. Agreed? And so tangents, normally 180 divided by 2 is 90. So this is how I use it. I say, okay, 90's there, which means this one's 45, which means this one's 22 and a half. So you see how I use period a little bit now this way. And phase shift is negative 90, correct? But how are we going to have to type it into the calculator? The red one that I wrote or the original that I gave you in the problem? Which way? Yeah. I wish I could write it the red way. Because when you hit tangent, what automatically happens? Without you doing it, you automatically get a parenthesis, correct? So you have to write it the way it was written in black here, because it's the only way we can get it in there. I wish we could. I'm wondering if they fixed that in the Inspire. Not sure. Well, I'll just clear it out this time so it's less confusing. What do we got there? Tangent, and then there's that parenthesis. There's that parenthesis I was telling you about. You can't put anything in there, right? So here we go, x. And then, nope, it should be 2x, right? 2x plus 180. Yeah, what should we do here? Because if we graph it right now, what's your window set at? Negative 360 to 360. This is going to happen a lot, right? So we might want to go ahead and check that window and see what's going on. So negative 360, well, that's not what we want right now, right? We want negative 90 to 90, right? Okay, negative 90 to 90. So what was each tick mark when we kind of went over there? 22.5, okay, 22 and a half. Good. How about y min and max? I would suggest either doing negative 5 to 5, negative 10 to 10, something like that. Now, if you have a number out front, that's going to help you. If you had like a 2 out front for your in the amplitude location, remember, this isn't really measurable, I would go even further. So what do you want to do? Negative what? Negative what? You did 10? Okay, we'll do negative 10 and 10 then. Again, you're still going to get a very similar graph if you do something else. I think, do you want to do each tick mark 5 then, or just let it put in 10 of them? Because the calculator is doing it anyways, right? So what does it really matter to us? Well, hopefully this works out. Yeah, the 84 is where they fixed one of the slight issues the 83 had, because asymptotes are not supposed to be graphed. And basically, here's what the 83 would do, because it kind of works left to right. It finds a point, finds a point, finds a point, and just keeps connecting them. And then it's, oh, the next point's down there is what it would say. Oh, so the calculator would say, okay, I'll connect them. Next point, next point, next point. And then it would say, oh, I'll connect it to the next point. And you got these lines just flying through there. Those aren't supposed to be there. Those are not actually part of the graph. They are imaginary kind of boundaries, okay? But can you even see them here, though? You can tell where the asymptotes are if you know to expect them, right? You should be able to tell where they are. And again, with the way we're doing it, keeping those tick marks so similar, we have such a much more knowledge of what's going on. And again, what should we do? If we're going to go to the table, I would set it up first, right? I would go 0, and this time it's 22 and a half, right? And now when you go to the table, it'll give you actually a little bit more accurate values as to what you're looking at. And look at what the calculator does for asymptotes. Error, right? At 45, it's at, sorry, not working. And why does it give you asymptotes or an error? What really happens there? Yeah. It's undefined, and why is it undefined? Dividing by 0, right? So that's a huge problem. Okay. So any questions on the graphing calculators? At least when it's with result of graphing these. Okay. So what if I took them and messed up all the settings? Do you think you could get it back to what you wanted it to be? Good. Excellent.